future is bright, especially if we build for it. Welcome to Architecting the Future, a podcast for the builders of tomorrow, all about people, process, and technology. We hope you enjoy the show.
Hey everybody, welcome back to Architecting the Future. I am really excited today to have James Urquhart from VMware join the podcast. James, thanks so much for stopping by.
Hey, it's my pleasure, man. I'm really excited for the conversation today. Thanks, Miles.
And from my little bit of time in the EMC family of companies, I know that principal technologist, there are a lot of principal technologists touching all kinds of cool things at VMware. So I thought for the audience, just to start, maybe you could introduce yourself and also touch on, Tanzu and just a little bit about the tool and what you work on day to day.
Yeah, for sure. My name is James Urquhart. I have a almost 35-year career in distributed systems development, deployment, and operations. I have, over the years, been at many different companies doing many different roles. I was VP of product for a company that was bought by Dell in 2013. I've had leadership principles at positions at Cisco, at Pivotal before the VMware acquisition, and a number of startups. But right now my focus is essentially representing the field and the field technologists as we build out this product suite that we call Tanzu. And especially focused on the developer experience side of things. So the developer platform, there's actually two that we offer. One is Tanzu Application Service, which is based on Cloud Foundry. If you want straight out of the box, it just works. You type in one command and your application deploys and all the magic happens. That's the one to go for. And then if you need a little more flexibility to kind of extend and change technologies and tailor it to your specific needs, then Tanzu Application Platform, built on Kubernetes, is the platform that we offer for that. And so still very much an integrated experience, but leverages a lot of Kubernetes principles to offer more capability to be more flexible with what you do. So those are the two primary product areas that I focus on in my day-to-day job, but I'm really kind of bringing that long experience I have with developers trying to build and deploy these distributed systems at scale, and trying to build a platform that really does what developers want it to do.
And I'm curious, when you are at this intersection of the customer and kind of, renowned enterprise sales team, like one of the most successful go-to-market teams that probably exists in technology, how do you find that balance of really knowing your product and, drinking the Kool-Aid, if you will, and be excited about it with you've been in the buyer seat where, you probably are, this like Docker versus this container architecture, like you're probably have a little bit jaded of how much the Kool-Aid should be drunk. I'm just curious, how do you think about that?
Yeah, it's a great question. And I think really the fundamentals of platforms are very, very simple, right? What platforms need to do is come in, and for whoever the platform is for, in our case, the software developers, it needs to do three things, but two that developers care about, right? So it needs to certainly increase profit in some way, either by reducing cost or finding new revenue streams. But what developers really care about is, can you reduce the amount of effort, like the amount of make work and just stupid junk I have to do, the toil? And can I reduce the things that can go wrong and get me in trouble and affect my reputation, the risk? And, that's a very broad statement. Most engineers also care about the company and also care about how they integrate with the overall strategy and things like that. But really, ultimately, what they want from the developer platform is essentially to take the language of software development and lift it up to the way they think about the code they're writing. So what's the unit of delivery? Well, at the very least, it's a executable file, right? That's the unit of that I'm building, or a WAR file or something along those lines, right? So I want to think in terms of deploying that, or even, and I think this is the smallest granularity we'll get to, a function. I write function by function. Oh, now I got to write this function. Now I got to write this function, right? So we get down to that mentality. and remove everything else. So if you ask developers, what do you want from the network in cloud computing? They'll give you an answer. They'll say, I don't want to know what's there. I just want to say that I want A to talk to B, and I want the following policy applied to that conversation. And that's it. Make it happen. And so that's really the role of a modern developer platform in any sense. Like in this, even what the public clouds are offering in terms of all the different services they have around development, what we offer and our competitors offer in terms of the enterprise multi-cloud space, or even the small little ones you might get for a specific language, like a Go environment or Rust or something like that. The ultimate thing that makes the developer want to use it is that it removes stupid work and it removes risk, and then they can turn their attention to, can I deliver something that changes the game?
Mm-hmm. And so I'm curious.
That's how I keep it kind of separate. Is I don't want to buy the Kool-Aid of, hey, we got there, we have the perfect thing. What I want to do is say, this is a constantly evolving problem. New tech comes in, new stacks come in, and everything. I want to be talking about this in terms of that transitional journey, in terms of the work VMware has left to do, in terms of the transformations that the customer has to make in order to be able to take advantage of these new approaches.
Yeah, well said. And my next question for you is, I know that you, sort of separate from the day job, have become a real expert on this idea of event-driven integration, written a book about it, just are very much at the forefront of this topic. So I wanted to ask you, and kind of focus in the next chunk of the episode on this, can you just explain to the audience, which is varying degrees of technical acumen, in lay terms, what is event-driven integration and why does it matter?
So I wrote a book on a topic that I call flow architectures. The term flow is super heavily overloaded in the industry. So to explain what I mean by it, is flow architectures are about event-driven integration. So applications communicating via events across organizational boundaries, that may be across divisions within a company or between companies, and using standard interfaces and protocols that mean that you don't have to write to that level of how do I receive the event and interpret it. That they're, basically that connectivity would be like HTTP is today. Most of the toil is taken care of you by libraries and things that are out there. And why is that important? Why is that a big deal? Why even write a book about that? Well, if you think about the effect that flow has on the way we communicate today across organizations, if it will significantly reduce the cost of integrating across organizational boundaries. So because you have standard interfaces and protocols, because you have libraries that already know how to do the basics of communication and picking out the payload and all that stuff, you don't have to write all that code. You don't have to negotiate a protocol or negotiate an interface between you and the producer or receiver or whatever you're talking about. And so that lowering of that cost by orders of magnitude means basically Jevons paradox kicks in. And if for the listeners who don't know what Jevons paradox is, Jevons was an economist in sort of the late 1800s that was paying attention to what was happening as the cost of smelting steel was coming down dramatically. And the idea was, so there'll be less money spent on steel because the cost is going down. But of course, that's not what happened. As the cost came down, people found new uses that were now economically viable for steel that weren't economically viable before. And the demand exploded, right? So you actually increased demand dramatically by lowering the cost of producing that. In the same way, if you lower the cost of integrating to receive real-time data, there's so much different use cases for consuming real-time data. You will explode the demand for real-time data. And so the tagline of the book basically is, like HTTP linked the world's information and created the World Wide Web, flow architectures are going to link the world's activity more so than it ever has been and create the worldwide flow. And that I'm not married to that term, but that was the term we could come up with in time for publishing the book. And I think it's a really decent representation of it's the movement of data between entities that find value in that data. It's a flow problem from a systems perspective.
Now, I'm curious, how does that marry with the world of security we're in, where right now, I mean, you have some huge concerns around opening up your pipes to each other. What's that marriage?
Yeah, and this is why at this point, I wrote the book almost 3 years ago. So there's like a 7.5 year time horizon on this starting to become a mainstream thing. And the real reason is because there's some big problems that need to be solved. And those include things like, how do we negotiate encryption? How do we make sure that only people that we want to access the data are able to access the data? But just as importantly, how do we make sure that if that data is passed on from a third party, that I have the provenance to know that that's the original data that was intended to be sent? Right? So these are not problems that are unsolvable, but these are difficult problems that need the industry to kind of come together and say, we need to do this the same. Excuse me. So what I have, what I kind of propose out of that is there are some standards that are starting to pop up. And there are also, at the same time, and this is very important for the evolution of a topic like this, there are prototypical flows, for lack of a better term, out there. They don't use the standards. They don't, they're cross-organizational boundaries and stuff, and all of that, but they don't, there's no standards that they're using. There's a lot of negotiation, but they are the beginnings of solving the problems of how do I keep this secure? How do I make sure that the data I'm receiving is the data that the producer intended to send to me? So, EDI has been doing that forever. If you've ever used electronic data interchange, that there's a ton of work that goes on there to make sure that what you're receiving is what was intended to be sent to you by the producer. And that's why it's a major, major protocol, often used in a batch format, but it's a major, major protocol used today. And so you kind of say, like Walmart today has a couple of different options for how you can send your inventory data if you're a manufacturer or if you're a warehouse to them to put up on their website. And that is prototypical in that it's not quite event-driven, but it is the flow of real-time data from multiple sources that they need to consume. And it's not quite standards, except they're using EDI and they're using REST. So there are some standards involved in it. They didn't go completely custom on everything. And so as they solve problems around that, if that stuff gets noticed, gets picked up in open source, and in other ways, then the evolution continues towards that thing that we can all use that begin to get us there. And I also know that the AWS team, the Azure team, I had people from Azure. I had one of the main principal event-driven systems architects at Microsoft was a contributor to the book. I had the inventor of NATS, one of the major messaging systems out there that's doing some really cool event-driven stuff today, was a contributor. And all of them kind of giving me input towards the direction that they're working on these problems in their respective companies. It is a noticeable. If we can do this, we solve customer situations and use cases. So that's sort of the kind of the key thing is we're early. We're not so early that it's still pie in the sky dream, because there's a standard called Cloud Events from the CNCF, Cloud Native Compute Foundation, that has a lot of traction right now, and it is a way of representing the metadata around a core payload of events in a consistent way, so that all these different systems can consume just even with mapped to different wire protocols, mapped to MTTF, mapped to HTTP, etc. And so that's a start, but we don't have a lot of standards about the payloads, which would probably be industry specific anyway. We don't have a lot of standards about the interfaces. How do I subscribe to a feed in a way that's secure, in a way that can be monetized, in a way that can have provenance and other things kind of recorded. So the start is there, the groundwork is there. The book has a whole big appendix at the end that talks about all these technologies that were out there, when I wrote the book, that are examples of things that are contributing to the core code flow concept.
And I'm curious, do you see in lay terms, the equilibrium being a third party marketplace, like a tool like Zapier, where you sort of get credits that you're paid and receive from? Do you see it being direct company integrations using frameworks like EDI where there's not a middleman? Is it going to be both? Like, what's your read of the monetization at scale?
Yeah, that's a great question. And to be really honest, there's no way to predict that. But based on what's happened in the past, what I would believe, I mean, if you look at HTTP, that's a great example, right? So HTTP is basically peer-to-peer in a lot of senses, except there are some big core data providers that have big core major functionalities of the internet that we rely on. So there's a gentleman by the name of Jeffrey West. He's a scientist at the Santa Fe Institute that they're famous for studying complex systems. And he wrote a book called Scale. And basically what he argues is that nature and human society and all these other kind of uncoordinated, uncentralized things end up building the same patterns for large amounts of flow through a large system. So if you look at freeways and surface streets and then neighborhood streets to houses, if you look at your body, and so you've got the core arteries and then they go out to veins and arteries that serve your limbs, and then eventually it all breaks down to capillaries that serve the cells. If you look at any number of things, and even if you look at the internet today, there's a lot of kind of core flow of data through core networking that happens to get you from point A to point B. And so that kind of concept makes me think that what will happen as this scales up is that there will be some sort of major sources of events for different types of things. They will be kind of core and central. I think the large cloud providers, to be really honest, probably can offer the service in an easier way to consume it than people installing it in their own data centers. And so there'll be a huge amount of central brokering that will happen in various ways on the major clouds. So you have EventBridge on AWS today, for example, and that already has pre-created integrations with whatever SaaS services you might be using as a business, all the kind of the major ones that are out there. And so you don't have to write the connection to that. You just sort of say, hey, here's my account, here's some other information, start sending me events, right? And so you already have sort of those kinds of central services that simplify the task. But I don't think it'll get to the point that there'll be some major vendors that own the world of event-driven integration, because I think the whole purpose, the whole definition of flow, and basically says, you don't even really need to use like an event broker at all. You could just do a web, when I'm thinking the Webflow or WebStream, whatever connection to a web server someplace, and have a direct connection that satisfies all the things I talked about earlier.
Mm-hmm. And that's where you think it's certainly in the enterprise. If you, like you said, look at patterns, you'll probably see direct connection in the enterprise, and you'll probably see some kind of broker in the less technical mid-market, just if that follows kind of consumption of our current systems.
That's a good way to look at it. I mean, I look at things like Epic in the healthcare space, right? And there are opportunities for people to be major owners of event streams if they're major owners of the production of that data and the production of those events. So the stock market and things like that. But I think ultimately nobody will kind of own the whole game. There are some interesting network mappings that are already happening. A company called Synadia, which is where Derek Collison, who created Nats, is now, his company now. And they're building basically a kind of a network abstraction on top of the internet that basically says, all you need to do is give me a topic name, and I will connect to that topic, and I will readjust where we're caching that topic to make it as efficient as I can for you automatically. You don't have to do anything around that, right? I mean, that kind of concept is like, hey man, if all I had to do for my interface was say, here's my topic, here's the key that I need to use to consume that topic, give me the data, then that interface is insanely simple to consume. And by the way, then if you have cloud events coming across that wire, you can figure out what the metadata tells you about the event type and the payload type and go from there. And it's just incredibly simple compared to what we have to do today, with the types of integration we do.
Yeah. And I'm curious, if anyone wanted to read your book, do you mind just plugging it? Where do they get it?
Yeah,
Maybe, we can get a picture.
Let me so this is the book on O'Reilly. If you have an O'Reilly subscription, you can read it online. It's also available in Amazon, all the major bookstores still to this very wonderful day. What I'll say about it is it's not a technical guide in the standpoint of like it gives you instructions on how to build the flow architecture. It is, I'm stepping you through the techniques that I use to validate to myself that flow is inevitable, that it has to happen. And, we could go for a while on that topic, but for sure, flow architectures, and, I write about this a lot in the book. There's a lot of kinds of analysis that you can do that indicate that we're moving in that direction, and there's huge value to be had when we get there.
And last question, if anyone wanted to reach out to you, is LinkedIn an okay way? Is email a way? What's the best way? Whether geeking out, we'll try to save you solicitations to your day job in the Tanzu world, but just if anyone wants to talk about flow architecture, is LinkedIn okay, or what's the best medium?
So LinkedIn is a great way to find me. Just I believe it's just J Urquhart, but look for me on James Urquhart. Another good way to reach me, you can feel free to DM me on X/Twitter, assuming that Elon still allows that.
Changes by the day, I think. Yeah.
So just grab the opportunities when you can. For sure, those are probably the two best ways to kind of just initiate contact with me today. I'm happy to talk to whoever about this topic. I think we're just in this wonderful kind of early transition period where there's not a lot of conversation about it, but you're starting to see it spin up, right? I'm doing this keynote in Nashville next week at Goto EDA Days, which is a joint AWS and this Goto Media company event. And basically asked to come and do the keynote because they just feel we're getting there, right? We're getting to that point where more people should understand the concept, and there's more opportunity to build around that concept than there was a couple of years ago.
Yeah, it's an exciting time. I think on our little podcast here, it might be that we interviewed the great James Urquhart before suddenly, he was the godfather of flow architecture. So we'll see. Might bump up our viewers. Yeah.
Or I'll be the Tesla and die penniless, whichever.
Yeah, very interesting. You look at Tesla himself, the company's named after, gave up all his designs for free to keep Westinghouse going, right? Isn't that a true story?
Exactly right. Yeah. He gave all royalty rights to Westinghouse in order to keep the company running.
You would have thought prior to the car company that Westinghouse got the better end of the deal, but it seems like Tesla's name's going to go down in history a little bit bigger as long as they can ship Cybertrucks, but we'll see.
Certainly in part because of the naming of the company, although this was happening a little bit before that, but people know, what a questionable ethicist that Thomas Edison was in comparison. So you have... you definitely have some good insight into what's going on. Not that Edison didn't do anything positive, but there were definitely, ways that things happened there that were very, very questionable. And you have, I think that, in sort of in parallel with all of that, right, you have a situation now where with AI and with other kind of approaches, the need for real-time data is changing really rapidly, right? For those systems that are trying to train on an ongoing basis, having an event stream like this would be awesome. But does it have to be in the format I'm talking about, right? Do you actually have to have a standard around that? Or is there some way that is going to evolve out of the AI world in a way that looks nothing like what I laid out? And I'm very clear about the fact that I can tell you that there's a movement towards this outcome in terms of consumption of data, but I can't tell you the form it's going to look like. That the market's going to figure out over time.
Yeah, I think that's a great point. It's interesting. Figuring out where the puck is going is the first path to then figuring out how to really skate to it. Because I think knowing that this is the future is important because it does change how we build today. But I think like ChatGPT, we know we should be using it. We don't really know what it will be used for in the future because right now it's not very good, but will probably be good in 20 years. It's like
When they
that
figure
weird
out
balance.
when they figure out how to keep it from getting more stupid as time goes by, then it'll solidify itself. But yeah,
The consequence of talking to humans, right, is we'll make it dumber over time. Yeah.
right, exactly. Well, that's what that's part of what's happening is it's getting more and more human data, and it's getting dumber. But yeah, I agree, and I think that this is It's good to have these overlapping like major revolutions happening at the same time, because ultimately, if they feed each other, that feedback loop, it's like having two waves kind of meet at the peak, right? You just sort of boost the amplitude of both hugely, and so it's a really good thing that's happening in that sense. And I 10 years from now, it's going to be a very different world from the perspective of how, when you do something online, how quickly the value of that action that you just took appears in other websites. So you go into systems that have to respond to that in terms of inventory or in terms of shipping, right? Like it's a very different landscape very quickly when you're able to sort of say, hey, when this happens, do this. So.
And I think one good thing too is the democratization of that process may decentralize a bit the concentration of power across a few of these platforms,
right,
which is probably not bad for humanity. Because like you said, right now it's a couple people living off event driven flows, like the social media platforms. The average plumber or something can't. I think the future is that you're going to see a democratization. It's probably just best for hopefully everyone that's not Jeff Bezos or Mark Zuckerberg on the scale. So it's interesting. Well, James, thank you very much for joining the show. It's a pleasure, especially I know you're in demand, like speaking next week and things. So thank you for your time, and look forward to continuing to follow this and have you back on as Flow Architecture continues to unfold.
Thank you very much, Mas. I appreciate it. Thanks for having me on the show.